Okay, if you break down the z-score formula, the z obviously stands for z-score. This x is probably the most complicated one or the most new. X just stands for an element in the list. So it could be a specific test score, it could be a specific number, or whatever else. That mu, just like before, is our mean. In terms of what we see in our calculators, it's x bar. And then the O with attitude is our standard deviation. Okay, so they could be asking us for any part of that. Now, in terms of the bell curve, this hasn't changed. This is still the mean. Okay, and then like before, remember this is 1 standard deviation away from the mean. This is 2 standard deviations away from the mean. And then this is 3 standard deviations of the mean. So remember, if I told you you're 1 standard deviation away from the mean, it could be a good or a bad thing. Z-scores are pretty much the same thing as standard deviations, but it's more specific. You could have a positive or a negative z-score. So all of these from this over would be positive z-scores. From this way over, they are negative z-scores. So if I told you, hey, congratulations, you have a positive z-score of 1, you know you're above the average, above the mean. Versus if I said you had a negative 1 z-score, then you're below. All right, so here is our list, and it says how many have a positive z-score. Well, you could sit there and you could, calculate each one, or we just need to draw our bell curve, which means we need to know what the mean is, we need to know what the standard deviations are, and then we're only going to take, if it's a positive z-score, we're only going to take this side, okay? So first and foremost, you need to grab your calculator, and we're going to put our list into our stat plot. So stat, okay, clear. Okay, stat, edit. Oops, what am I doing? Clear, push down. All right, so 30, what was it? 50, 60, 80, 70, 50, 60, 80, 70, what was the last one? 30, 30. Okay, stat over one variable statistics. So our mean is 53.33. So 53.33. And then our standard deviation is 18.86. So 18.86. Okay, so then to find the positives, since I only want the positive z-scores, I'm not going to even worry about these negative z-scores. So I would add 18.86 to all of them. So I would say, all right. So I can sit there and I can add 53.33 plus 18.86 and so forth. I'd get 72.19, and I could keep going. But really, I know that if it's a positive z-score, if it's anything greater than 53.33. So anything greater than a 53.33, I would say, all right, 60 is definitely one, 80 is definitely one, 70 is definitely one. So I would have 3 positive z-scores. Okay? All right, here's the next one. Jill made a 95 on her test. So she made a 95. The mean of the class was a 70. So the mean is a 70. And the z-score is a 10. What is the standard deviation of the test? So I start by writing my z-score formula. Once again, I knew to write my z-score formula because it mentions z-score in the problem. So now I just plug in what they gave me. Jill made a 95. So that's the element, okay? So Jill making a 95 is going to go here. Then it says a mean of 70. The mean is here. And then last but not least, it says a z-score of 10. Z-score goes here. So now I just plug in what they gave me. So z-score is 10 equals 95 minus the mean was a 70 all over standard deviation. So to get rid of that fraction, I have to multiply by the denominator. So I'm going to multiply both sides by the standard deviation. Those cancel, leaving me with 95 minus 70. And then 10 times standard deviation is just 10 standard deviation. Okay. 95 minus 70 is 25. And now I just divide both sides by 10, giving me that my standard deviation is a 2.5. Now, just to make sure that makes sense, we can draw our bell curve. They told us that the mean straight up was a 70. Okay. And then we know that Jill her z-score is a 10. So she is way over here. If her z-score is a 10, she's way above the curve. So if each standard deviation was 2.5, this would be 72.5. That's one z-score away, one positive. Then I would add another one, which would make it 75 and so forth. And then if I went 10 times, I would get to 2.5. So that makes sense. Here's the next one. Jacob made a 45 on his test. The standard deviation was 12. All right, so Jacob made a 45 on his test. The standard deviation was 12. His z-score is a negative 1.5. What was the mean? Okay, so z-score equals x minus mu over standard deviation. So we know that if Jacob made a 45 and he's got a negative z-score, the mean obviously has to be above a 45, right? Because we have to now make over. So what we know so far, we don't know the mean, but we know the standard deviation is 12, and we know that he has a negative z-score, so he's going to be somewhere over here. That's what we do know. All right, so the z-score they told us was negative 1.5. He made a 45 on the test. We don't know the mean, and the standard deviation is a 12. Okay, so we start by multiplying by the denominator, which is 12. So 12 times negative 1.5 gives me negative 18. Bring down my 45 minus mu. Subtract 45. Negative 18 minus 45 gives me negative 63. And I still have a negative mu. And then I need to divide both sides by negative 1, giving me a mu of 63, because two negatives makes a positive. So my mean is a 63. Now let's go back and make sure that makes sense. So my mean was a 63. My standard deviation, remember up there they told us was a 12. So if I take one standard deviation away, I would subtract, giving me 51. Take one more standard deviation away, I would subtract 12 more, giving me 39. So if it's a negative 1.5 z-score, this was one standard, this is two standard, so he should be somewhere in here, right? Because it's a negative 1.5 z-score, and sure enough, his score was a 45, which is in the middle. Okay, I think this is the last one for practice problems. Kaylee's mean when running is a 4.5. So her mean is a 1.5. If her standard deviation is 1 mile, so standard deviation is 1 mile, and her z-score for today is a negative 12, so her z-score is a negative 12, how many miles did she run today? Start by writing our formula. The z-score is a negative 2. We don't know how many miles she's ran. The mean is 4.5, and that's all over the standard deviation, which is 1. Okay, so let's go ahead and draw our bell curve real quick. They told us that the mean is 4.5. So on average, she does about 4.5 average miles. And then if honestly, we can say, okay, you told me the standard deviation is 1. So if it's 1, this would be 5.5, 6.5, 7.5. If it's minus 1, 3.5, 2.5, 1.5. So we don't even have to do math without, so if she's negative 2 z-score away, we know she's here because that's negative 2 away. But let's go ahead and do the math to prove it. We multiply both sides by 1. 1 times negative 2 is negative 2. Then I would add 4.5 to both sides. X equals 2.5, which like I said up here, same thing. Okay, so once again, standard deviation and z-score are the same thing. It's just z-score tells you if it's negative or positive, which standard deviation does not. It takes on either side. Here are your practice problems. Go ahead and have those ready for tomorrow.